So we're going to start by reviewing what we did last time, which is parametric equations. So you have an x equals and a y equals, and they're both in terms of this parameter, which is t. So I'm going to get you started on this one, and then I'm going to like pause the video and let you try it for a second. Okay. You want to make a table for your parameter and then for x and y. When you graph it, it's still an xy coordinate plane. The parameter doesn't show up there. It's just both of your coordinates are in terms of t. Okay, so what numbers are we going to put in for t? Because usually that's given to you.
-2.
What else? Well, I'd like more than just that. -1, 0, 1.
All right.
This is what I got. Is this looking like
Yeah.
what you got? And I usually like cover up the t row so that I don't end up looking at that when I go to plot them over here. So I'm starting at -7, 12. And then -5, 3. And then this is the direction that it's going to go. Like we're starting at this point, and that's the direction we're going to go. -3, 0, -1, 3. So it looks like what kind of a shape here? Parabola. And whenever we eliminate the parameter, which is the next thing that we're going to do, we should get something that is an equation of a parabola. Like there should be a squared in there. Okay. To eliminate the, or does that look like what you all? Okay. I feel like that's easy peasy. Whenever you eliminate the parameter, you're going to solve one of these for t, and it doesn't matter which one, but usually there's like an easier one and a harder one, so you want to go for the easier one, and then take it and plug it into the other equation. So which one would be easier to solve for t? I would go x, and the reason why is when you would have to get rid of the squared, what would you need to do? And then you end up with like a plus minus situation, and then that's just not fun. So I would solve this one. All right, so welcome to algebra. How would we start getting t by itself for that? Yeah, add 3, so we'd have x plus 3 equals 2t. Sorry, I just came over here because that's where I had space. And then yeah, x plus 3 over 2. So you're going to take that and substitute it in for t in the other equation. So you get y equals 3 times all of that squared. Now, let's say it was a multiple choice question and they told you to eliminate the parameter. They would not leave it looking like that. So we're going to have to square everything that's in the parentheses. So x plus 3 squared would just be x plus 3 squared. 2 squared would be 4, and that's totally fine like that. I'm just going to rewrite it one more time to bring the 3/4 out front because I feel like that looks a little bit better that way. I don't know, that's just my opinion. And then you want to say, hey, does that make sense? Does this look like this graph? Do you remember your transformations? It's been a while. Like you did those in algebra 2 and pre-calc. Remember how this moved left 3? It's kind of backwards from what you would expect. Does this graph move left 3? Yeah, that's where the center is. It's squared. It's a parabola. Okay. Now your x values would have to stay between what two numbers? Because we always talk about what our domain is after that. So x has to stay between what two numbers? Same as we were given for t. It's just these are our x numbers because this is y in terms of x. And then number 2, also review what we did last time. We're going to write parametric equations for this, and then we're going to force the curve to go through the point 3, 1 at time 0. So when you write parametric equations, you need an x equals and a y equals, and then they're both in terms of t. What do you think about for x? Let's do that one first. You would want it to go through 3, that's our x coordinate there, at time 0. Make it as least complicated as possible. What can I put in here like with a t so that if you plug in 0, you would get 3? T plus 3. Go for the easiest thing possible. If you plug in 0 for t, you're going to get 3. You could make it more complicated, I suppose, if you want, but like, don't do that. And then you would take this and plug it in for x in the other equation. So it would be 2 times t plus 3 minus 5. And then you just, distribute, combine like terms, all of that. That would be 2t and then what? It would be plus 6 minus 5, so 2t plus 1. And then what I would usually say to do is make sure that that one makes sense. If you plug in 0 for t, do you get what you're supposed to get? Like y is supposed to be 1. Okay, just make sure it makes sense. So that's what we did last time. That's what a parametric equation is. Now we're going to venture forward and do derivatives with them. Okay. So if x is in terms of t and y is in terms of t, this just means you have equations with x equals and y equals, and then you have t over here. Then the slope at x, y is dy dx equals, that's our derivative. It is dy dt over dx dt. Oops, and I can't write and talk at the same time. And so what that means is you do the derivative of y with respect to t, you do the derivative of x with respect to t, and you just put one over the other. You know how to take derivatives. None of that information has changed. This is the only thing that's new. Okay. And then the second derivative, so we're going to put the little 2's in there. So it doesn't mean you're squaring the derivative. That's notation that means second derivative. You're going to do dy dt of like the derivative of what you just did. Or I'm sorry, just d dt. Why did I stick a y in there? I was like, why am I doing that? You're going to do the derivative of what you just did. That's what a second derivative is. So do the derivative of what you just did. And then it goes over dx dt again. What I relate that to is, do you remember when we did acceleration? And the units were feet per what? Like position was feet, velocity was feet per second, and acceleration would be feet per second squared. You're dividing by those seconds again. It's like feet per second per second. Is that making sense? Like you divide by that again. It's like this is a velocity, this is an acceleration. So you do the derivative of what you just did, and then divide by dx dt again. Think of the feet per second squared. That's where like that is. So horizontal tangent line, that's a 0 slope. That would be where dy dt is 0. So that's where your numerator is 0. And then a vertical tangent line. What kind of slope does a vertical line have? What do we call that? Slope of a vertical line. Undefined. That's where your denominator is 0. So that's going to be where dx dt is 0. Because oftentimes that's what you get asked for, is horizontal tangent line or vertical tangent line. So horizontal is dy dt equals 0. Vertical is dx dt equals 0. We all on board? Okay. You know how to take derivatives, so you're just kind of putting it all together. So we're going to use these parametric equations: x equals sine t, y equals cosine t, 0 to 2 pi. Find dy dx. You're going to do the derivative of y over the derivative of x. All right, so what's your derivative of y? Derivative of cosine would be negative sine. So derivative of cosine gives us negative sine. And then over, now you're going to do the derivative for x. Derivative of sine is cosine. Or have we forgotten how to take derivative? Do we remember the trig ones? Okay. Now I want to, because we're going to do a second derivative, I want to kind of simplify this down. It is going to be negative. Do you remember what sine over cosine is? Good. Okay, well remembered. Because if you can simplify that, then that's going to make your life easier for like the next part of the problem. Let's see. So negative tangent of t. So we just did the derivative of this over the derivative of this. Now when you do the second derivative, you're going to do the derivative of what you just did, like any other time you've done a second derivative. So the derivative of what we just found, and then just divide by dx dt again. So what is your derivative of negative tangent? Well, it's going to be negative. What's your derivative of tangent? Secant squared, good. And then you divide by dx dt again. So here's x. What did we say dx dt was? What was our derivative for x? Yeah, derivative of sine gives you cosine. And that can actually be simplified a little bit further as well. It'll be negative because we just have that negative out front. Cosine is the reciprocal of secant, or secant and cosine are reciprocals of each other. So how could we write that? It would be negative secant. Well, it's squared right now, cubed, because if you flip this, you would get another secant. So negative secant cubed. Basically, just if you like reciprocate that back, it would be another secant. You'd have secant squared times another secant. So you have secant cubed. Letter C, at what points is there a vertical tangent line? Vertical was that dy dt equals 0 or dx dt equals 0? All right, we want dx dt to equal 0. And there could be more than one answer here. It's point or points, plural. So what was our dx dt? What was our derivative for x? Cosine. So cosine equals 0. And we're going to have to find values, t values, where cosine is 0, and it's just once around your unit circle. Cosine's x, so where would that be 0? Pi over 2 and 3 pi over 2. Here's the thing. It said at what points? A point is x comma y. We found the parameter, but you need to go back to the original equations and plug those in to actually get the coordinate point. It's exactly what you did over here in the table. You know how you plugged in t values and got x, y? It's the exact same thing, okay? So let's plug in and get those 2 points. So first let's do pi over 2. Plug in for x. Sine of pi over 2. Good. Comma. And then plug pi over 2 into the y equation. Cosine of pi over 2 is 0. So 1, 0. And there's going to be another point. We're going to plug in 3 pi over 2. So plug in to the x equation. Sine of 3 pi over 2. Negative 1. And then for y, cosine of 3 pi over 2 is 0. Now I'm going to show you some fancy stuff in the calculator so that you can see this visually. No, a union is when you're doing like a increasing, decreasing thing, and you're saying like we're increasing from here to here, union here to here. These are two specific individual just points. So it's not appropriate to like put a union there. You can just put and or a comma or nothing, I guess, if you want. But yeah, not a union. All right, so look at your calculator. We're going to change some things in mode first. So if you can go to mode, it's right here next to second. First of all, you should always be in radians. So if you're not, go put that in radians. And it's especially important for this question because we are doing trig. The radians actually won't make a difference unless you're doing sine and cosine, but we are, okay? Now go down a little further. Do you see where it says function? What does it say right next to that? Go and put it in parametric mode. So go down to parametric and hit enter. All good? Now, when you hit y equals, you will see that it looks different. You'll have x equals and y equals for the first one. So let's go ahead and type those in. It's x equals sine of t. Now, when you hit your variable button, this one right here, you know how usually it puts an x? What did it put? That's why. Have you ever wondered why it said x comma t comma theta comma n? T is for parametric. Theta is for polar, which is what we're going to do next. And n is for those sequences and series. Those are what all the different things on there mean. Okay, so now you've moved on to the second one, which is the t. Okay, so sine of t. And then go down to y. Y was cosine t. Don't hit graph yet. I have another thing I'm going to show you. You want to go to window. And we're going to fix our window to be what's given on the paper here. So do you see where it says T minimum and T maximum? What were we given for our domain for T? Yep. So make it 0 to 2 pi. pi is right here. It's the exponent key, but you have to hit second to get it. Now, when you move away from there, it's going to make it a decimal. It should say 6.283, blah, blah, blah. The t step, okay. That's how often it puts another pixel on the screen. Just leave it whatever it is. Mine's 0.13. If you make it too big, your points will be too spaced out. Do you remember the little Desmos activity we did last time, where it ended up being very like rectangular, and then you clicked on smooth curve and it smoothed it out? If you make your t step too large, it's going to make the points too far away from each other, and it'll be really boxy instead of smooth. If you make it too small, the calculator will try to put the points too close to each other, and it will do that thing where it's like thinking forever, and it will never actually get there. So you want it like a small number, but not like 0.0001 or anything. Is this making sense? Like, okay, so just leave it whatever it is. And then the x's, you do want these to be rather small because it's going to be a small graph. I'm just telling you that because I know that ahead of time. Make them all -2 to 2 with a scale of 1. And I'm just telling you that because I know what this graph looks like, and I know what this graph looks like. When you hit graph, make sure you look, because it's going to happen fast, what the orientation is, because it's going to graph it in the orientation. So go ahead and hit graph. It's not just any circle, it's actually the what? Actually the unit circle. Sort of. Okay, let me go back. Here, I'll type this again, because if I type it again, it'll redo it. Watch up here. Note where it starts and what the orientation is. So it started here and it went clockwise. But the unit circle starts there and goes. So it looks like the unit circle, but the orientation is not correct and the starting place is not correct. And that is because for the unit circle, what would x be? X would be cosine and y would be sine. So reversing them messed that up. Is that like cool? It's cool, right? It's cool stuff. Very cool. Do you want to do another one, or do our brain break here? Do another? Okay. There's not like a whole lot. You guys know how to take derivatives. We're just applying it to a parametric equation. All right. So find dy dx. You're going to do dy dt over dx dt. So look at y. What would be our derivative for y? Good. 2/4 reduced to 1/2. So 1/2 t. Ooh, do you remember derivative of square root? This is one you want to just try to know. It's 1 over something. 2 square root of t. It's 1 over 2 square root. So when you divide by a fraction, you multiply by the reciprocal. So this would be 1/2 t times 2 square root of t. And so what's going to happen there? The 1/2 and the 2 will cancel. And I want to write it as a fraction exponent because we're going to need to do a second derivative. This is t to the first. This is t to the 1/2. So it's t to the 1.5, which would be 3/2. And I just wrote it that way because we're now going to do the derivative of that. And it's just easier if you have it written that way. All right, so here we go. Second derivative. Do the derivative of what you just did. And then you're going to divide by dx dt again. And think of that as like your feet per second, right? So derivative of this, what would that give you? I know, fun with fractions. Oh, it would be t to the 1/2, which would be square root of t. Are you good with me just writing it as square root of t? Are you comfortable with that? Okay. It would be 3/2 t to the 1/2. All right, over, and then you're going to do dx dt again, which was 1 over 2 square root. And then that's like a lot of fractions there. When you divide by a fraction, you multiply by the reciprocal. So it's going to be 3/2 square root of t times 2 square root of t. And then you just clean that up a little bit. So what will that come out to? And 6 halves would be 3. So just 3t. So it actually turned out nice in the end because the roots canceled out. Square root of t times square root of t would just be t. Letter C says, find the slope and concavity at this point. All right, well, slope would be first derivative. Concavity would be second derivative. Here's the thing. You can't plug in 2 or 3 to these. You have to plug in t. So you have to figure out what the parameter is. Now you have a choice. You can plug in 2 for x or 3 for y. You want to pick the equation that's easier. So which one of these looks easier? Like has less mess in it? The x one, do you see that? Okay, so x is 2. What would t be? What's our parameter? If x is 2, what is t? Which would be 4. The square root of 4 would give you 2. So our parameter is 4. All right, so slope, that's going to be first derivative. That's this one right here. So it's 4 to the power 3 halves. Pretend it's a 1/2. This is what I always say to my pre-calc students. We're actually just doing this unit right now, the exponential unit. Pretend it's a 1/2. 4 to the 1/2. That would be square root of 4. Be 2. But then then you cube it. So 2 cubed is 8. Here's the point though. It's positive. So if it's positive, what does that mean the graph is doing? Increasing. Good. Do you remember increasing because derivative is positive there? Like all that fun stuff. Okay. Same thing. We're just applying it to a parametric because they could ask you that on the AP exam. Is the graph increasing or decreasing at this point? And you would say the graph is increasing because derivative is positive at that point. All right, concavity. We're going to plug 4 for our parameter into the second derivative. That's an easier one. 3 times 4. 12. The point is, though, that it's what? Not so much that it's exactly 12, but good, it's positive. So what does that mean the graph is doing there? Concave up. Because second derivative is positive then. Oh, and this one is asking for an equation. What 2 things do you need to write an equation? Slope and a point. They gave us the point. We just need the slope. Now again, you can't plug in 4 or 63. You have to plug in t. So you have to figure out what the parameter is at that point. And again, I think x is the easier one. If you plug in 4 for x, way back here in the beginning, if you plug in 4 for x, what's the parameter when x is 4? 16. Square root of 16 would give you 4. So your parameter is 16. You have to figure that out because these are in terms of t, not x or y. So slope comes from the first derivative. That's this one right here. It would be 16 to the 3 halves, which I get is really weird. But pretend it's 1/2. What would be 16 to the 1/2? 4, and then cube it. So 64. That is one heck of a slope, right? Up 64 over 1. It's like practically vertical. Are you getting that? Like it's pretty steep. All right. But this is your point. This is your slope. Just assemble your equation. Do you remember how to write an equation? It would be y minus 63, good, equals 64 parenthesis x minus 4. Lovely. Cool. Okay, so we just want to take a look at this first. Did you get that? Oh, I'm sorry. I can see it. There, does it look like that? A little loop-the-loop?
Yeah.
That's cute. That's a cool graph. These are neat. So we get to do like cooler graphs now. Not a function, but it's still a good graph. So letter A says, write both. So there's going to be 2 of them. Tangent line equations at the point 0, 2. So look, do you see how right here is 0, 2? The reason that there's 2 of them is that one is going to go through this way. You can have a tangent line at that point. And the other is going to go through this way. You can have another tangent line at the same point. Isn't that wild? One's going to be positive and one's going to be negative slope. Are we seeing that? One will come through like this. I can't draw on the calculator screen, so I can't draw it on there, but one will come through like this. Okay. So we need our derivatives. Let me just write right above here. We'll do dx dt and dy dt. And so what's our derivative for x? Two minus pi cosine t. Good. Pi is just a coefficient there. Remember, pi is just a number, 3.14. So it just is the coefficient, right? So 2 minus pi cosine t. Derivative of y. Good. And why is it positive?
The negative sign.
Good. Derivative of cosine would be negative sign. Negatives cancel. And what happened to this two? Yeah, it's a constant, so it's gone. Okay, here's the thing. Just like the problem on the other side of the paper, this is x and y. These are in terms of t. You need to figure out what the parameter is to be able to plug into it. So which one looks easier to plug into, x or y? Not the derivatives, but just like the original. We found the derivatives, that's cool, but now we need to figure out what t is. Would you want to plug in for x or would you want to plug in for y? Because there is an easier one here. Y is correct. Why is x like not a good idea? You have two of the t's in there. It's going to make it way harder. All right, what are we plugging in for y? 2. So you would have 2 equals, and then that equation, 2 minus pi cosine t. And then welcome back to pre-calculus class. You're going to have to solve that. So what would you do to start solving that? Yeah, minus 2, which is conveniently going to give you 0. Divide by negative pi, which is 0 divided by anything, is 0. And so you need places on your unit circle where cosine is 0. We actually already looked at this today. The unit circle is very, very repetitive, just sort of by nature. So where there's 2 of them. Pi over 2. Oh, and good. You have to stay on this interval. So pi over 2, and I think you guys said the other one, negative pi over 2. Good. Good. Because usually people want to say 3 pi over 2, but do you see how that's not on this interval? Like we're stuck from negative pi to positive pi. Okay. So now we're going to get our slopes. First, we're going to plug in pi over 2, and it's dy dt over dx dt. So we're going to plug into this one and then fraction bar and then this one. So if you plug in pi over 2, sine of pi over 2, 1 times pi is just pi. Fraction bar, and then we're going to do this one because again, it's dy dt over dx dt. All right, if you plug in pi, cosine of pi, 0 times pi is still 0, and then 2 minus 0 is 2. All right, and then we're going to do the negative pi over 2. So again, we're going to plug in here first. Sine of negative pi over 2. You have to think like you rotated backwards, so it's going to be down at the bottom. Negative 1 times pi, negative pi. And then if you plug negative pi over 2 in here, cosine of negative pi over 2 will be 0 times pi is 0. 2 minus 0 is 2. Now, this is a very weird coincidence. I don't want you to walk away thinking this is going to happen all the time. But do you see how we plugged in pi over 2 and we got pi over 2? And we plugged in negative pi over 2 and we got negative pi over 2? That's just like a weird coincidence, okay? But these are the two slopes. And do you see again how one's positive and one's negative? Because one will come through like this. That's going to be the positive one. One will come through like this. That would be the negative one. And they're both at this point, 0, 2. So we're going to write 2 equations, one for the positive one, one for the negative one. So the positive one, it would be y minus 2 equals pi over 2 parentheses It'll be x minus 0, which would just be x. I just tend to write the whole thing just to be thorough. And then the other one's going to look the exact same, except with a negative pi over 2. And I ended up with a little bit of extra space, so you know what, I'm going to draw it for you. It does something like this. And so here's the positive tangent line. And then here's the negative tangent line. So you can visually see, like, are you seeing it? Good. All right, and then last one. At what points is there a horizontal tangent line? Horizontal, would that be dy dt or dx dt equals 0 for horizontal? Dy dt is 0. So we found that right here. It's pi sine of t equals 0. And then we're going to solve that. Welcome back to pre-calc class. What would you do to both sides? Yep, divide by pi, but that's still going to be 0. And you need t to be on your interval, which was negative pi to positive pi. So 0. And sometimes I'll put pi after that, like it's no pi. Not finished, though. That's the parameter, but the question says at what points? So your answer needs to be x comma y. How could we get that? Yep. Plug it in. Plug in 0 for t to these original equations, not the derivatives. We want the actual point this time. All right, so if you plug in 0 for t in the x equation, that would just be 0, right? And then sine of 0 is 0. So 0 minus 0, 0. So x is 0. And that's why I like to put the pi there for that one. Because like that's no pi, but this is just the number 0. Like I get that they both come out to be 0, but that's why like there's a distinction there. All right, and then we're going to plug in 0 pi to the y equation. Cosine of 0 is not 0. It's 1 times pi. So 2 minus pi. And I want us to look at that on the calculator because you already have it typed in. Bring up your calculator. Do you see how right here is where the horizontal tangent line would be? Like at the bottom of the loop. Okay. See your trace button, how it says calc above that? You know how you've done that with regular rectangular equations all the time? Do that. Do calculate. Second trace. You want to do a value, so choose 1. And what do we want to plug in for t? 0. Put in 0, enter. And do you see how it's that point right there at the bottom? That's where the horizontal tangent line would be. And what does it come out to? Negative 1.1415. Well, that's 2 minus 3.1415. Is this like, I like to do the visual because that helps wrap it together and make the connections, because otherwise it's just very abstract. So I like to look at the picture.